Dear learners, how are you? I think you are all well. In the previous class, many students of my honors level students have requested me to conduct a class in English. So, I have a little step to conduct this class in English, and the topic is calculus. I think these topics will be helpful for SSC, honors and master's level students in this devastating corona period. This is Goutom Biswas, Assistant Professor of Mathematics, Government Bangabandhu College, Gopalganj. From very beginning of this class, I have to give some idea about what is calculus, what is its creator or inventor, and some related topics such as domain, codomain, function, relation, and other related terms. In the previous class, I have stated that if you combine infinite small points, then it forms an area or a plane or a surface. This is the idea of integration. On the other hand, if we divide this surface and at last it reaches to a point, and this is the idea of differentiation. So both integration and differentiation are the idea of calculus, and what we have seen here, the change of a point or rate of change of infinite small points is occurred here, and this changes of infinite small points or rate of change is vastly discussed in calculus, which was vastly discussed or improved by our scientists Sir Isaac Newton, Leibniz, and other scientists. So they are called creator and inventor of calculus. Now, if you have the well idea of set, and if you want to have the well idea of relation and function, I think you can consider a machine. And suppose you can take an item such as wheat, and you put wheat into the machine, and then you will get two items. These two items are flour and husk. So you input one item in the machine and you get two items. So this is one kind of relation. And in these examples, three items are given, and in every cases these are input, and a machine will process this item into two items, that husk and flour, paddy, rice and husk, sesame, oil and oil cake. On the other hand, if you see these examples, sesame, one item, and you will get oil. Mustard, one item, you will get oil. Mango, one item, you will get juice. That means here one is elements of first set, you will get one output. That means one element of second set. In this set, this is the set of son and this is the set of father. Suppose if you call Shabu, then Obi will come. because Avi is father of Shabu. Then Saki, Bashu, Hashu, Mithu. Here is also, you can see that Shabu is related with Avi. Shaki is related with Bashu. That means one element of first set is related to only one element of second set. Okay? And in this 1, 2, 3, 4 and 5 examples are given here. And among these examples, you can see that one element of first set. That means each element of first set relates with one or more elements of the second set. First set A, second set B. That means if you take one item of the first set, each item of the first set, you will get one or more items of the second set. This is the relation. So what is the definition of relation? Two sets, non-empty set, and they are all real number. Two non-empty sets are related in such a way that corresponding to each element of first set or one or more elements of first set, you will get one or more elements of second set. Here one element, that means each element of first set, you will get one or more element of the second set. This is the indication of relation. But among these relations, see the examples, these three, 1, 2 and 3 examples. These three examples, this and this. In these examples, you can see that each element of first set relates with only one element, unique element of second set. Why? Sesame oil, mustard oil, mango juice. Here each element of first set relates only one unique element of second set. This example is same, this example is same. So we can easily define such special types of relation as function. So what is function? Function is one kind of relation where if two non-empty set A and B of real numbers are related in such a way that corresponding to each elements of first set relates with only a unique element of second set, then these special types of function relations is function. Here the definition is given that I have already stated to you. Okay, so this is function, and this is function. This is and this is. These three examples are function. Okay, so here we can express it as f is a function from A to B. Here A is domain and B is codomain, and f of A is range of the function A. We will discuss firstly about domain, range and codomain after these topics. Now, condition of function. So what is the condition of function? First condition, each elements of first set must relate with only one element. So this is not function, this is only relation. But in these examples, each element of first set relates to only one unique element, only unique elements of second set. These examples, and these examples. These three examples are the function because each element of first set relates with only unique element of second set. Number two condition. Here, see the examples. Here, 1, for 1 we will get 3, for 2 we will get 4, for 3 we will get 5, for 4 you will not get any image or any output in this set. So we can easily understand that here 4 doesn't take parts in this relation. So second condition, what is the second condition? Second condition is that if all the elements of the first set doesn't take part in relation, then their relation will not be function. In this examples, 4 doesn't take part in the relation because there is no image of 4. 4 is the input, but there is no output of 4 in the second set. Okay? So two conditions. These conditions are already clear to you. Now we can give the definition of function as variable. Suppose two relations are given, y equal to x, and if you put x equal 1, then we get y equal 1. If you put x equal 2, then you will get y equal to 2. So if you put each element, each value of x, you will get one unique element of y. Okay? So this relation is function. On the other hand, take another relation, y square equal to x. That means y equal to plus minus root x. Plus minus root x. If you put x equal 1, if x equal 1, then y equal plus minus 1. If x equal 4, then y equal plus minus 2. So what is happened there? It's really true that, and you can easily observe it, that if you put one value of x, you will get two values of y. One value of x, but you will get two values of y. So we can say for each element of x, we will get two elements of y. So what is the definition of a function in the form of a variable? If two variables x and y are related in a such a way that corresponding to every or each element of x, each value of x, there exists only a unique element. There exists a unique element of y. Two variables x and y are related in such a way that corresponding to each value of x, we will get a unique value of y. Then the relation between these two variables is defined as function, and this is the definition of function in the form of variable. So this is function, but this relation is not function. On the other hand, you can define or you can give the graphical representation of function. What is graphical representation of function? Suppose this is a relation or a curve. This is x-axis and this is y-axis. This is x-axis and this is y-axis. If you take any value in the x-axis, suppose 1, then the line parallel to y-axis, you will get two values of y. Here first value and here second value. Here you input one value of x. Input one value of x, but you will get two values of y. One value of x, but you will get two values of y. So according to the function, definition of function, this relation is not function. On the other hand, if you set x and y axis in the same way, this is circle, this is also half circle hemisphere. This is if you put any value of x, you will get only one value of y. That means for each value of x, if you take any value along the x-axis, you will, in every cases, you will get only one value of y. Only one value of y. One value of y. Unique value of y. So, this is function. On the other hand, set this x, if you this x equal 4 suppose, this is straight line parallel to y axis, and if you take here x equal 4, then you will get infinite values of y. Infinite values of y everyone lies on this straight line, which is parallel to y axis. So here one input but infinite many output. One value of x, infinite many value of y. That means if you put any value of x, you will get infinite values of y. So this is not function. Also, this is not function, because if you put x, then you will get two values of y here and here. Also, if you put here, then you will get two values of y here and here. So this is also not function. This is only relation. This is the graphical representation. Also, if you take y equal to 4, then what will happen there? Here, draw the picture. Y equal to 4, 1, 2, 3, 4. This is the straight line. If you put any value of x, you will get only one value of y. Any value of x but one value of y. So any input of the first set, you will get only unique, that means a unique element of second set. And this is the graphical representation, whether the function is exist there or not. Now, on to function. It's very important for you. Many students who have not clear idea about on to function, they can easily take their real idea from this class. My dear students, see here, this is relation, this is not function, and this is not function. Now you can follow these three examples. These three first examples, here two input, but they are same output. The input of this item is oil, output of this item is oil. So you can easily see that the output oil is from both sesame and mustard. That means two individual elements of the first set, but we'll get only one image. That means same elements in the second set. So this is function, but this is not function. This is not on function. On the second example, what we have seen here, Shabu. Obi is the father of Shabu. Basu is the father of Shaki. Mitu is the father of Hashu. This is the set of son. This is the set of fathers. So if you call Shabu, then Obi will come. If you call Shaki, Basu will come. So in this set, two individual elements. Every individual elements and their image, that means output is also individuals. So the individual Shabu output Ovi, individual Shaki output Basu, individual Hashu output Mitu. Okay, so this is the relation between first set and second set, and this relation is function, and also it is a one-on function. In this set, here two same elements of first set, that means two individual input but same output, that means same image. So what is the definition of one-on function? If the individual elements of the first set of two non-empty set are related in such a way that each individual elements has the individual image in the second set. That means every individual elements of the first set relates with individual elements of the second set. Also we can define in this way: individual input and individual output. Also we can define in this way: no two individual elements of set A have the same image. Here two individual elements but same image. Here individual elements but not their image is same. So we can easily give the definition of one-on function if the individual elements of first set has individual elements in the second set. Or we can define in this way: no two individual elements have the same image in the second set. What is image? Image is the elements of second set that relates from first set. That means Shabu's image is Obi, Shaki's image is Basu, Hashu's image is Mitu, but Mishu is no image. Mishu is not image of any elements of set A, because there is no element, there is no son in this set who is the son of Mishu. So Mishu will not image for any elements of set A. Okay? So this is the definition of one-on function. Now definition of one-on function as variable. Suppose y equal x, then if you put different value of x equal 1, you will get y equal to 1. X equal to 2, you will get y equal to 2. So different elements of x, different values of x, but we get here different image, that means different value of y. So this is one-on function. But here y equal to x square. Here if you put x equal 1, then you will get y equal to 1. If you put x equal to minus 1, then you will get y equal 1. Here different element of first set but same element of second set. Different element of first set but same image in the second set. So this is not one-on function, but this is one-on function. Now we have to define if a function is one-on. If a function is one-on and one-to, then the function can be turned into an inverse function. Okay? The function can be turned into inverse function if it will be both one-on function and one-to function. Okay? Then the original function domain will be the range of the inverse function, and range of the original function will be the domain of the inverse function. In this way, the two terms will be changed for both of main function and inverse function. Now, one-to function. What is one-to function? One-to function. onto function. Follow this example. Here you will see that this is the domain and this is the codomain. And what is the image of this function? Image of Shabu is Obi. Image of Shaki is Bashu. Image of Hashu is Mitu. Image is the range of a function. So Obi is an image, and it is a range. Bashu is image, it is a range. Mitu is a image, it is a range. So there are three ranges because these three elements, these three persons are related with Shabu, Shaki and Hashu. But Mishu is not related to any man of the first set. See easily. You can see easily. So Mishu will not be a range. Only Obi, Bashu and Mitu are range. So these four elements are codomains. But among these four elements, among this codomain, Obi, Bashu and Mitu are only range. So here we can easily see that this is a function, and in this function there are three ranges, Obi, Bashu and Mitu, but codomain is defined previously that are Obi, Bashu, Mitu and Mishu. So here codomain and range are not equal. When the codomain and range are not equal, the function is not onto function. Okay? But here range is the image of Shabu, range is a range, Salma is the image of Shajid, Salma is a range, Salma is also image of Hashu, Salma is a range, Rina is the image of Hitu, so Rina is a range. So here three ranges, Renu, Salma and Rina. This is the set of ranges. Previously we can easily see that these three men, Renu, Salma and Rina, these are also codomain because codomain is already defined, and we give a definition in the form of function, and then we easily express to you that what is domain, codomain and range. Now it will be clear to you. Okay? So here Renu, Salma and Rina, these three persons are range. Also these three persons are codomain. So in this set, codomain and range are equal. So this is a one-to function. This is a one-to function. On the other hand, if you see here, if you put into a machine, this is function, this is function, this is function. If you put sesame into a machine will process sesame and you can get oil. Mustard can be processed by machine and you can get oil. Mango can be processed by machine and you can get juice. So these three items are domain and these three items are codomain. But oil is obtained from sesame and mustard. Juice is obtained from mango. So input and we get the output, oil and juice. This is image. And these two images are also range. But previously we have discussed this set totally codomain. So in this function, codomain and range are equal. So this function also onto function. So what is the definition of onto function? If in a function the codomain and range is equal, codomain and range is equal, then the function will be called onto function. And if the function is onto function, I have already discussed it. If the function is 1 and 2, then it will be it can be turned into inverse function. When the function will be both 1 and 2, then it can be turned into inverse function. Okay, my dear students, our time is so short. and within this short time it's very tough to mention all items of calculus. I have tried my best to give the whole idea about function, one-on function, one-to function, difference between relation and function, and next we will try to find out the domain and range of function. In this corona time, you should keep yourself well, and I think you will feel well, and you should try to read and continue your studies. I think my item will help you to prosecute your studies in this corona time. Thank you all. Next, I will come with you with good topics. Best of luck.